Good morning there, my fellow mathematicians. Today we are going to be looking at factoring our quadratics, but the difference is it's when a does not equal 1. So students will be able to factor a quadratic when a, and this means does not equal 1. Okay, and I'm calling it using X factor part 2. Okay, 7-5 is done, so we're starting 7-6. Okay, we've actually done a little bit of this with X factoring, or with filling out the X. So now you'll see why when I divide those two numbers by A, you'll see the reason why we do that. Okay, so what is it that we're going to learn? We're going to learn how to factor a quadratic when A does not equal 1. Why? Again, because factoring helps us solve, graph, and simplify quadratics. Okay, how do we know if we've accomplished today's what? Given a quadratic, one that when a doesn't equal 1, we will be able to factor it. So this is what I'm talking about here. We have a quadratic because it's a square, and my a value, the number in front of x squared, is 2. So that is something that does not equal 1. So 7-5, the one we just quizzed on, all of those, everything that had you guys actually factor, the a value was 1. Okay, so same process. It's just when we divide those two side numbers on the x, we'll divide by something other than 1. Okay, and that changes the number. All right, so let's check it out. Here's an example. So we have a quadratic. We're asked to factor. So what we do is we say, hey, let's try x factor. Okay, so in order to x factor, we need to know our a, b, and c values. So a is 2, b is 1, and c is -6. Remember, there's a hidden 1 right there. So remember, the top number is a times c, so we actually have to multiply 2 times -6, and we get -12. My b value is 1, and we need to think of two numbers that, remember, they multiply to -12, and the two numbers add to 1. So I know 4 and 3 make 12, and 4 minus 3 make 1 if you add them. So it's going to be 4 and -3. But remember, we have to divide by a. So I'm going to divide by my a value, and my a value is 2. So I'm going to put a 2 under each of these numbers. And at this spot, okay, when you're at this point, you need to make sure you reduce if anything's reducible. So 4 over 2, that reduces because 4 divided by 2 is 2. But -3 over 2, 3 over 2, they don't reduce. So I'm going to leave it as 3 over 2. So this 2 becomes x plus 2. And then this here, this -3 over 2 becomes x minus 3 over 2. But the thing is, now here's what we got to remember. Like, here's something that a lot of students forget. Okay, you can't have your factor with a fraction in here. So in order to alleviate that, what we do is we take this denominator, this 2, and we just bring it to the front. Okay, not the numerator, we take the denominator, the bottom. Okay, so let me ask you, do we take the top or do we take the bottom? Okay, we take the bottom and we bring it in front of the x. So I'm going to take that 2 and bring it in front. So I end up with x plus 2, the quantity x plus 2, times the quantity 2x minus 3. Okay? And the reason why we're allowed to do this is if we solve this 2x minus 3, okay, and we'll end up doing that later on, we'll get the same answer as if we solve x minus 3 over 2. Okay, but this is the simplified way. You don't put fractions in your factors. Okay, so we got to get used to that. And this is what's called factored form. Okay, this is the factored form of the original quadratic expression. And again, if we multiply this out, we would end up with this. Okay, so let's look at another example. So again, we have a quadratic. So what are we going to do? We're going to x factor. A times C is on top and B is on the bottom. So these are my values, right? Remember there's a hidden 1 right there, but there's a negative in front, so it's a negative 1. A times C is 3 times negative 2, and that gives us negative 6. B is negative 1, and I need two numbers that multiply to this and add to this. So I know 3 minus 2 is 1, but if I make it negative 3 with a positive 2, that would give me negative 1. So those numbers there that we have, those aren't right because we want it to be negative 1. So let me fix that really quick. So that needs to be negative 3, that needs to be positive 2. So that means this is going to be the negative or the minus, and then this one will be the positive plus. Because I got to change this one, this one. Okay. So let's go to that, get to that point again. So negative 3 times positive 2 is negative 6, and negative 3 plus positive 2 is negative 1. And then we got to divide by a, and we're going to divide by 3. So again, at this point, you got to look at your numbers, look at your fractions, and see if anything reduces. Well, negative 3 divided by 3, well, that becomes negative 1. That should be negative 1. And that stays as 2 over 3. So let me, sorry about that. Perfect. Okay, so this becomes an x minus 1 because that was a negative 1, right? And then, I mean, if you want to go right into it with this 3 in front and make it 3x plus 2, that's fine. But I'm going to keep the 2/3 and then I'm going to move the 3. Okay, just so you guys know where it's coming from. Remember, we always take the denominator. We take the bottom number if this factor is a fraction. This one's not a fraction, so we don't have to worry about it. Okay, so we end up with x minus 1 times 3x plus 2. And you guys remember what this is called, what form it's called? That's right, it's called factored form. So we have factored this original quadratic expression. Okay, so I'm going to do another one with you guys. Because there's different circumstances. I just want you guys to see everything. All right, so again, we have a quadratic, so we're going to x factor. A times c goes on top and b goes on the bottom. So a times c is 6 times 4, which is 24. B is 11. Let's put 11 there. And I need two numbers that multiply to 24, but also add to 11. Okay, I mean 12 and 2 make 24. 6 times 4, but the numbers we're looking for are 8 and 3, because 8 times 3 is 24, and 8 plus 3 makes 11. And then we divide by a, so we're dividing by 6. Okay, so this one's different because if you look at both of these fractions, they both can reduce, but they don't reduce to an integer, like what you guys would say is a whole number. They reduce and they're going to stay as fractions. So we have to reduce each of these by a common number, and each of these are reducible by 2. So I'm going to divide this by 2 and that by 2, and that gives me 4 over 3. And then over here, I can divide both of these by 3. So I divide the top and bottom by 3, and I end up with 1/2. So I have x plus 4 over 3, and then I have x plus 1 over 2, and then I'm going to bring each denominator, not the numerator, I'm going to bring the denominator over. So I got 3x plus 4, I bring this over, I get 2x plus 1. Okay, and I think the animation is going to come right there. Yep, I forgot to move it. It's okay. All right, so You guys try one if you need to. You can rewind the video, um, take a look at what I did, just follow my process. Okay, again, it's not much different than what we did in 7-5. We're still x factoring, still doing a times c on top. Okay, the only difference is there's a 2 instead of a 1. So 2 times 5 is 10. Still the b's on the bottom. Two numbers that multiply to 10 that also add to 7. That should be an easy one. 5 times 2 is 10, and 5 plus 2 is 7. But we need to divide by a. Okay, so we're dividing by 2. 5 divided by 2 does not reduce, but 2 divided by 2 does. So we're going to turn it into 1. So now we have to write them as factors. So that's x plus 5 over 2. And if you wanted to, you could have brought the 2 over right away. Here we got x plus 1. Okay, I'm going to bring the 2 over now. And I end up with 2x plus 5 times the quantity x plus 1. Okay. So I just want you guys to try one more. Okay, this is actually a problem from the book. Actually, these last two are from the book. All right, so a times c on top, that's 10 times 3, which gives me 30. B is 17. So we need to think of two numbers that when you multiply them, you get 30, but when you add them, you get positive 17. Okay, it might not be obvious at first, but it's an easy one. Okay, 15 times 2 is 30, and 15 plus 2 is 17. Okay, but what are we dividing by? We're dividing by a, we're dividing by 10. Okay, and these are both reducible. Just like example number 3, they're both reducible. Okay, this fraction over here, both of these are reducible by 5. And then over here, they're both reducible by 2, so we have to reduce them. So I'm going to divide top and bottom by 5. So that would be 3 over 2. I'm going to divide top and bottom by 2, and that becomes 1 over 5. So now I'm going to write each of them as a factor. Okay, don't forget, you bring the denominator over, the bottom number. This bottom number comes over right there. Becomes 2x plus 3. This becomes 5x plus 1. And the animation was off a little bit there. Okay, so if you guys were able to do this, this particular example, you're doing really good. Hopefully this helps. And if you guys ever, if you need to, you can always rewind, watch it over again. But thanks for watching.